The architect's gambit. Quick question. Have you ever shipped something, then spent weeks cleaning up a security mess you wish you caught earlier? That is exactly what this session fixes. Welcome to the architect's gambit. In chess, a gambit is a small sacrifice early to win big later. In architecture, the sacrifice is a little time upfront, so you do not pay for breaches later. On this slide, you can literally see the usual wreckage: SQL injection, broken authentication, cross-site scripting. Today, we flip the script, threat modeling, and risk assessment, so your design starts hostile to attackers by default. The alarming cost of hindsight. This is the money slide. Security fixed early is cheap. Security fixed after release is brutal. The red arrows show the pain curve. As you move from requirements to design to development to testing to post-release, cost explodes. Because in production, you are not just fixing code. You are doing incident response, emergency patching, customer trust repair, and sometimes legal and PR damage control. The goal is simple: push security decisions left when it is still just a diagram. Pinpointing the moment of maximum leverage. Here is the leverage point. Architecture and design. Most teams treat security like a final gate, a test at the end. That is backwards. Security is a lens you apply early. If trust boundaries are wrong, or data flows are unsafe, you cannot patch your way out later. Architecture is where we decide what the system believes, who it trusts, and what gets verified. Adopting an adversary's mindset. This is the strategic shift. Builders ask, does it work? Is it fast? Is it scalable? Great questions. Attackers ask different ones. Where is the weakness? Where are the trust boundaries? What can I exploit? What path gets me privilege? So for the next few minutes, you are not just designing features. You are designing how your system behaves when someone tries to abuse it. A systematic approach to paranoia. Threat modeling is paranoia with a process. 4 steps. 1. Decompose the system. See it clearly. 2. Identify what could go wrong. 3. Rank what matters most. 4. Choose what you will do about it. That is the entire playbook. And now we walk it. Step 1. Data flow diagrams. Step 1 is your security blueprint. The data flow diagram. Key idea. We map data movement, not code logic. Squares are external elements, users, third-party services, anything outside your control. Circles are processes that transform data. Data stores are where information lives. Arrows are flows. And the most important symbol is highlighted here: the trust boundary. Anytime data crosses that line, it must be validated, authenticated, and authorized. Miss the boundary, miss the attack. A web application blueprint in action. Now, we use the diagram like an X-ray. Customers and remote employees both reach the corporate website. Then the database. Ask 3 questions that match the callouts on screen. Is 2-factor used where it matters? What validation happens every time data crosses that boundary? Is customer data segmented from employee access? This is the point. You spot architectural gaps before a single line of code is written. Step 2. Brainstorming with Stride. Now we find the threat categories. Using Stride. Memorize this. S. Spoofing. Pretend to be someone else. Authentication problem. T. Tampering. Changing data. Integrity problem. R. Repudiation. Denying an action. Logging problem. I. Information disclosure. Leaking data. Confidentiality problem. D. Denial of service. Taking it down. Availability problem. E. Elevation of privilege. Becoming admin. Authorization problem. We apply Stride to every element on the diagram. Applying Stride to the blueprint. This slide shows how to stop guessing. Users introduce spoofing and repudiation risks. Data flows introduce tampering and disclosure risks. Processes like the web server are targets for denial of service and privilege escalation. Once you map Stride to specific components, threat discovery becomes systematic, not random. Step 3. Ranking risk with Dread. Now you will have a long list of threats. You cannot fix everything, so you rank. Dread is a fast scoring method. Damage potential, reproducibility, exploitability, affected users, discoverability. Score each, average it, and you have a quick severity signal. Later you can use formal scoring like CVSS, but Dread is excellent for architectural triage. The prioritization matrix. Now we translate scores into a decision map. Likelihood versus impact. Top right is the danger zone. High likelihood, high impact. That is where issues like easy SQL injection live. Lower left is low impact, low likelihood, sometimes acceptable with sign-off. This is where security becomes a business conversation. You are not saying, I feel it is risky. You are showing where it lands on the map. Choosing a mitigation strategy. Once risk is ranked, you choose a strategy. Mitigate. Reduce the likelihood or impact with controls. Avoid. Redesign to eliminate the risk. Transfer. Shift risk contractually or through insurance. Accept. Formally acknowledge and move forward with leadership sign-off. The key is intentional choice, not accidental exposure. A catalog of countermeasures. This is your cheat sheet. Spoofing, strong authentication, protect secrets, tampering, authorization, hashes, digital signatures, repudiation, audit trails, timestamps, information disclosure, encryption and privacy controls, denial of service, filtering and throttling, quality of service, elevation of privilege, least privilege and input validation, threat plus control. That is how architecture becomes actionable. The payoff. From vulnerable to secure blueprint, here is the win. Before, the design is flat and trusting. After, the secure blueprint adds boundaries and mediation. Notice the separation and the improved path to the database. Fewer direct trust jumps, more control points. This is what it means to build security in, not bolt it on. The architect's lasting impact. Final thought. Threat modeling is not a checklist. It is a mindset and a repeatable skill. Your best security control is not a tool. It is a well-considered design created by someone who routinely asks, how can this be abused? And what will we do about it? If this helped, save this video and apply Stride and Dread to your next design review. That is how you win the architect's gambit.